Hello friends, I Agrawal and the today's topic is the analysis of three jars having the support at a different level. Now after watching this video, a student will be able to calculate the support reaction and also a student will be able to calculate the internal forces of arch having support at a different level. Now this is numeric. A 3-inch parabolic arch having a span of 30 meter and a depth of support from the crown are 4 meter and 16 meter below. It is subjected to UDL of 30 kN per meter to right half portion. Find normal thrust, radial shear at a distance the 3 meter left from left hand support. Also find the maximum positive and negative bending moment. Now this is a parabolic arch having a span of 30 meter and this support are the below the ground from 4 meter and the 60 meter. So this distance is a 4 meter and this distance is 60 meter. And is subjected to UDL of 30 kN per meter on the right half portion. So here draw a horizontal line and apply here the load on the right half portion, that is 30 kN per meter. Now this is a total span, but this is a one parabolic arch from A to C, from this A to C, and C to B is another parabolic arch having the different span. So suppose this we called as the L1 and this is called as the L2. So this we denote as the H1 and this we denote as the H2. So first is to find the L1 and the L2. For the parabolic arch, this is a formula. This L1 divided by L2 is equal to under root H1 divided by under root H2. Now we can replace this H2 by this total L. This is the total L. So that is the 30 meter. So we can replace this L1 divided by 30 minus the L1. This total span 30 minus L1 get the L2 is equal to under root. Here H1 is a 4 meter and S2 is a 60 meter. So if you solve this, we got here L1 is equal to 10 meter and L2 is equal to 20 meter. Now once you got the L1 and L2, then we proceed here the support reaction that we know. Here is a one support reaction is called as VA. This another support reaction is called as VB. Also here one the horizontal reactions and here is H. Also here the reaction is the H. Now next is to find the vertical and horizontal reaction. Now for that, here we are taking the bending moment at this crown, here at the crown. So bending moment at crown hinge. When the support at different level, we cannot directly calculate the support reaction. We have to take the bending moment at a crown hinge. We know is a crown hinge. So here bending moment is a 0. So we can say that here this is equal to the 0. This is equal to the 0. Now we are taking this bending moment from left hand side. So always we know bending moment is the bending moment at this hinge, that is equal to B moment minus the thrust moment or H moment. So now at here we are taking bending moment at here. So here is what this create this VA is create the second bending moment VA into the L1. This is a B moment. Now the H moment is what? H into this Y. So this is the 4 meter. So we can say that here that bending moment is equal to this VA into the L1 minus the thrust moment is H into the H1, and that is equal to 0 because we are taking moment at hinge, and that is equal to 0. So VA into 10 minus H into H1 is equal to the 4 is equal to 0. So we can say that VA is equal to 4H by 10. So that is equal to 0.4H. So here we got VA is equal to 0.4H. Now again we are taking here the bending moment from the right side. Bending moment at hinge. Bending moment at hinge, that is equal to 0 from the right side. Again the formula that bending moment at hinge, that is equal to the B moment minus the thrust moment. So B moment first is what, and that is equal to the 0. That is equal to 0. So B moment here. Now from the right side here. So this is one reactions. So this create the second bending moment. So VB into the L2 is a second bending moment, and this load create the hogging bending moments. Or simplicity, we draw here one simply supported beam for our sake of convenience. Suppose this is VA, this is VB, this is load here, and we know this is a 20 meter, and this intensity is the 30 kilonewton per meter. So first B moment is what? At here B moment. So VB into the 20 is sagging, and 30 into 20 into 10 is a hogging. So we can say that here. So VB into 20 is sagging minus is 30 into 20 into 10 is the hogging, and then minus the thrust moment, that is minus H into here. In our case we are taking moment at here, so this H into this total height, that is the 16 meter. So that is the H2, that is the 16 meter. So minus H into the 16 is equal to 0. So we can say that here VB into 20 is equal to this 16H minus plus here 30 into 20 into the 10. So VB into 20 is equal to 16H plus this becomes the this becomes here 30 into 20 into 6000. And VB is equal to 16H divided by 20 plus 6000 divided by the 20. So we got here VB is equal to this 16 by 20 is a 0.8 H plus the 300. So here we got VB is equal to 0.8 H plus the 300, and previous one VA is equal to 0.4 H. Now here apply the sigma Fy condition. Sigma Fy condition, that is upward positive and downward negative. We know here upward is VA plus the VB and downward is the UDL, that is the 30 into 20 total loads, that is equal to the 0. So VA is equal to 0.4 H, then plus VB is equal to 0.8 H plus the 300, then minus 30 into 20 is equal to the 0. So here we got H is equal to the 500. Now let us do 300 divided by, that is the 250. No, that is the 250 here. It's 250 kilometer. Then we put this value of H into the VB, and also in the VA we got here VA, we can say that VA is equal to 0.4 into 250, so that is equal to the 100.4 into 250, that is the 100, and VB is equal to the, what is the formula is 0.8 H, so 0.8 into 250 plus the 300, so we got here the 500. We got VA and VB. Now next step is to calculate the internal forces. So here this VA is equal to the 100 kilonewton, and this VB is equal to the 500 kilonewton, and this H is equal to the 250. Now the internal forces. Now first we calculate the radial shear. Radial shear. Now what is here? Internal forces at the location is 3 meter from the left support. So location is 3 meter. So radial shear, that is the Q. The formula is the V cos theta minus H sin theta. Now here is a V shear force at the 3 meter. Shear force at 3 meter. So we know here the beam. This UDL is for the 20 meter. This is a 10 meter. This VA is equal to the 100 and this VB is equal to the 500. So at 3 meter we want the shear force. So we can say that the shear force at this location 3 meter, that V is equal to the 100. V is equal to the 100. Then theta. So we know the formula is that tan theta is equal to 4h divided by L square into L minus the x. Here is the here is the span. Now here important the concept here. Now we want this 3 meter. So this is our arch. So this arch is what is L1, having the half span is L1. So we want the span of this location. So span is what? The support level at the same level. The span is what? This is called as the span. L1 plus the L1. So for this arch, where the support is a 4 meter from the left hand support, the span for this arch is the L1 plus the L1, twice L1. Distance between the support at the same level, that is the span. Distance between the two support at the same level, that is called as a span. So this is L1. For this we are taking from the left side here. So this support is a 4 meter from the left support. So again apply here from the 4 meter. So this is called as a span. So this is what? L1 plus L1, that is the twice L1. So here we can say that theta is equal to tan inverse of 4, h is equal to the 4 divided by this L1. This L is equal to the 10 plus 10, that is the 20 meter. So divided by 20 square into 20 minus the 3. So we got here this theta is equal to 29.24. We know h is equal to the 250 meter. So put the value in our equation. So Q is equal to B, that is the 100, cos 29.24 minus h is 250 into sine of 29.24. So we got here the Q is equal to minus 34.85 kilometer. Then next is the radial shear. Next is the normal thrust. That is equal to the V sin theta plus h cos theta. So we have all the values. V is equal to the 100 sin 29.24 plus 250 into cos of 29.24. So that is equal to 267 kilonewton. This value here. So here we got the Q and the N. Next part is the bending moment. Now here. Now first we want the maximum positive and negative moment. For that we have to draw the bend moment diagram. So here, suppose we draw the BMD. So BMD for the simply supported beam, BMD for the simply supported beam. Now we know here this is our beam. This is the load 30 kN per meter, and this is 20 meter. This is 10 meter. This is with 100 kilonewton. This is 200, 500 kilonewton. So now if you take the bend moment at this C, suppose this A, B and C. So bending moment at C is equal to what? Is 100 into the 10. So that becomes the 1000 kilonewton meter. So we can say that here this part is the straight and this part is the, and this is the 1000 and this is the positive. Now superimpose this here, the suppose that we know and that is the H into the H, where H into the H. We know that hinge the bending moment is the 0, so that is like this. So this is a negative diagram, so this part is negative and this part is above the line is a positive. So we got here negative bending moment is on the left side. So this portion is the negative and this portion is the positive. So here we got maximum negative bending moment on the left side. But we don't know the location. So first for that you have to write the bending moment equation and then derivative it and equal to the 0. We got the bending moment maximum on the left side. So for this maximum bending moment, that is equal to, we know B moment minus the H moment, minus H moment. So B moment, that is equal to, from the left side here is X, suppose. So VA, that is the 100 into the X, then this is B moment is only the 100 into X, then minus H into the Y, H into the Y. So H is equal to 250 and what is the Y? We know Y is equal to here X minus this 250. We know Y is equal to 4HX for this parabolic arch divided by L square into L minus the X. Now here is for the left hand portion. For the left hand portion, look here. For the left hand portion. Now this is the, suppose bending moment is at a distance X. Now left hand portion is what? Is H is equal to the 4 meter. So our span becomes L1 plus L1. Our span becomes L1 plus the L1. So we can say that here this is equal to 100x minus 250 into 4, H is equal to the 4 into X, and here this L is equal to L1 plus the L1, that is the 20 square into 20 minus X. So here we got the equation that is equal to the 100x minus 200x. We got here the equation 100x is 250 multiplied by 4 multiplied by 4 divided by is 20 square. It is 250 into 8 divided by 20 square that is a 10x. Here is a 10x into 20 minus the x. We got here the 100x minus 200x minus 10x square. Now here for the location of maximum bend moment we have to derivate here dm, or we first simplify this, that is the 100x minus the 200. So this becomes here the minus 100x minus the 10. Now here this minus and this minus become the plus. So we can say that this is the plus. This is a plus. This is the minus 100x plus the 10x square. So dm by the dx, and that is equal to the 0. We get here the location of the maximum negative moment. So dm by dx, that is equal to, this becomes minus 100, this becomes plus the 20x is equal to 0. So x is equal to the 5. So maximum negative bending moment is equal to, put this value into this equation. So minus 100 into 5 plus the 10 into 5 square. So we got here minus 250 kilonewton. So maximum negative bending moment. Now next part is what is the maximum the positive bending moment. So we know here by this diagram we can say that is maximum positive bending moment is on the right part. You have to take the x from the right part. Now here take the x from the right part, from the here. So here again the b moment minus the h moment here. So b moment is what? This is x. Suppose we draw here. So maximum positive bending moment, again that is the b moment minus h moment. We know beam is equal to like this, the span, this is the 500, this is 100, this is 30. So here this is x. So b moment is equal to what? Is 500 into the x minus is 30 into x by 2, 30x square by 2. This is the b moment minus h into the y. So again here y is equal to, we know is 500x minus the 15x square minus, we know is h is equal to the 50 into y is what? 4hx by l square into l minus x. Now for here this l is equal to the L2 plus the L2, because here the same case is here. Now from the right side here this support is what? Is 16 meter below the support. So this is the L2. So total span is like this. This L2 plus L2 is the total span of for this support. The span is what? Is the distance between two support at the same level. So at the same level, when this, if we drop at the 16 meter, so this span is called as the span of that arch. So L2 plus the L2. So take here. So we can see that here is equal to 500 x. Here this becomes 20 plus 20, that is equal to the 40 meter. So 500 minus 15x square minus 250 into 4 into here h is equal to 16 into x divided by the 40 square into 40 minus x. Now for the maximum bend moment we have to derive this equation. So dm by this dx, so that becomes here, or final equation here first. So here that is equal to the, this is equal to 100x minus the 5x square. Now the dm by dx, that is equal to 0. So here dm by dx is equal to the 100 minus the 10x, and that is equal to 0. So here x is equal to the 10 meter. So put this value into this equation. So we got here maximum positive bending moment is equal to 100 into the 10 minus 5 into 10 square. So that is equal to the 500 kilonewton. This is maximum positive BM. Okay, thank you.